Yesterday we talked about ions, and we talked about counting the protons, the neutrons, and electrons in ions. But one thing you might be wondering is, where do these charges come from? Let's start with some review vocabulary. First of all, remember an ion is just an atom with a charge. It'll have a little plus or a little minus by it. Next, protons are the positive particles in the nucleus of the atom, and the electrons are the negative particles that surround the nucleus of the atom. So in our picture below, you can see there are 11 protons and 11 neutrons on the outside, as represented by those red dots. Another new vocabulary word we have is called valence electrons. And valence electrons are the very outermost electrons on the atom. So if we look at our oxygen atom below, we want to count up only the electrons on the very last ring. And if we count those up, we have 1, 2, 3, 4, 5, 6 valence electrons. Next, atoms on the periodic table want to have a full outer shell. They are the most stable when they have a full valence shell, or the full outer shell. So what does that look like? Well, that means anything in row 1 or close to row 1 wants to have 2 electrons around it. Because if you look on the periodic table, our first row has 1, 2 elements in it. If we go to any of the other rows, like our second one here, we can count up 1, 2, 3, 4, 5, 6, 7, 8 valence electrons. So 2 electrons for row 1 and 8 electrons for all the other rows. So what's the easiest way to get to a full ring? Well, we have 2 atoms here. The one on the left is sodium. It has 11 protons. Now, sodium could get to a full ring by 2 ways. It could either add 7 electrons to the outside to get to 8, or it could lose that 1 electron and go down to the next shell. So again, we can either add 7 or lose 1. So the easier way to do that would be just to remove the 1 electron. And if we remove something that's negative, then the charge becomes plus 1. So we remove 1 negative particle, and now our charge becomes plus 1. If we look at oxygen could either get rid of the 6 valence electrons, or we could add 2 electrons. In this case, it would be easier to add 2 electrons, and therefore we would get a negative 2 charge because we would be gaining 2 negative particles. So let's look at the periodic table, because it's set up in a very specific way. The number of valence or outer electrons goes with the row that the atom is in. So notice how we skip over the entire middle section of the periodic table. That part we're just going to kind of ignore for now because it doesn't really work the same as the outer stuff. So our very first column has 1 valence electron, and then 2 in the next one. Then we skip over that big block, and then we have 3, 4, 5, 6, 7, and 8 valence electrons, with the exception of helium, which has 2 because it's the second element. So the valence electrons help us tell what the charge is going to be. If we only have 1 outside electron, or 2 outside electrons, or even 3, it's going to be easier to remove those than it is to gain up to 8 electrons. So things on the left side of the periodic table, it's easier for them to lose electrons. Remember, losing negative particles means that we're going to form something positive. So on the left side of the table, those atoms form positive ions. And on the right side, it's easier for those to gain electrons because they're closer to 8. Those form negative ions. So for sure, if you have a copy of the periodic table, or you can even just sketch an outline of one, the charges on the periodic table are going to align with the group. So everything in the first column will form a +1 charge. Everything in the second column will form a +2 charge. And just like the valence electrons, we skip over everything in the middle, and then we have a +3 charge. Now, when we get to the 4s, those kind of can go either way, because 4, we can add 4 or remove 4 to get to 8. So those charges will switch. And then we go one row over, then we're at -3, go one over again, -2, and then -1. And then the last column will not form charges because all of those in the last column have a full valence or outer shell. So make sure that you mark somewhere all of the ion charges on the periodic table as well as the valence electrons. And even though they have similarities between the valence electrons and the charges, and in fact, the valence electrons tell us how to get the charges, remember those are two different things.